Okay, we are ready to start. Thanks everyone for joining me. These are just the opportunity to get some help with your courses if you're having any trouble. I have the schedule up on the screen that you should be able to see, that we're going to spend 15 minutes on completing the square, 15 minutes on any questions you have, 15 minutes on how to use a graphing calculator, and then 15 minutes for more questions. You can either unmute yourself and actually tell me your questions. Keep yourself muted for the most part because there's background noises and stuff, and it's hard when you have multiple people with multiple background noises. But when you want to ask a question, feel free to unmute yourself. And we'll also use the chat box a lot. So if you haven't brought the chat box up yet, you probably should. Sometimes people will type in questions there, and you might feel a little lost because you can't see the questions. There should be something somewhere that says chat. I have 3 dots I click on that then I see I can open a chat box. So that way you can interact and ask questions as we go along, or I will ask you guys questions and you can respond. Oh, and I should introduce myself. I am April Barton. There's 3 math teachers. You may have me, you might have Karen, you might have Janae. Karen Whitehead or Janae Russell. We're all here to help, and we just want to answer any questions you have about the course. So, completing the square is a topic in algebra and in Algebra 2. It's in the 2nd semester of algebra and the 1st semester of Algebra 2. And it's about solving something called a quadratic equation. You'll see this over here. This is a quadratic. Right now it's only an expression. There's no equal sign. We'll get to the equation part, but we need to talk and have a little bit of setup before we can get to the solving part. So you'll notice I have this expression here, some parentheses with the squared. This is called a binomial because there's 2 terms. X is a term and 5 is a term. Welcome, thanks for joining. Right now we're going to talk about completing the square. So with a binomial expression like this, if we're going to square it, squared means to multiply something by itself. We're used to seeing like 5 squared, where you do 5 times 5, and that gives you just one number. When you're working with an entire expression, when you square it, you still write it 2 times, and you're going to multiply it together. So to multiply this together is kind of a long process in and of itself. And again, we're doing some build-up to actually get to completing the square, but it helps to have this kind of basis before we actually do the completing the square. So when we multiply this out, we follow the process called FOIL.
Yeah, I'm looking at your transcript.
F stands for do the first term times the first term in each parenthesis. X is the first thing in each parenthesis. So when we multiply this out, we do X multiplied by X. Does anyone already think they know what that's going to equal? What does X times X equal when you multiply it together?
Oh no, we have those.
And remember, you could either unmute yourself to answer, or you could write in the chat box to answer.
So let me see what we have. This will work. This is great. Okay, so I'll forward this to our transcript specialist. And we'll get yeah, we have.
Well, X times X, I didn't hear or see any answers. X times X, when you multiply it together.
Oh, yeah.
Oh, there we go. Now we have an answer. That is X squared. That is correct.
This is great. So we just had your...
Technically what you're doing is 1 times 1, because each of these have a coefficient of 1, which still leaves you a 1 in front, which we don't write in. And then since we're multiplying 2 variables together, since there were 2 of them, we get the squared. So now we're going to do the O of FOIL. That means outer times outer. Instead of looking at each parenthesis separately, you're looking at the very front and the very last, the outside of all that stuff together. So x multiplied by 5, this time we don't have two variables, so we're really only going to worry about the coefficient and actually do the multiplication of 1 times 5 to get 5x. Then we do the I is inner times inner. Again, instead of each parenthesis, we look at the whole thing. So the inside of all of that stuff written, that's another 5x, because 5 times x gives you another 5x. And then L is last times last. So the 5 times 5.
I'll tell you this, okay? I don't work in a portal very often. I don't.
So when we combine this together, now we get x squared plus 10x plus 25. This combines together to give us this trinomial. So the whole point of doing that is because completing the square, that's our ultimate topic right now, is completing the square. When you're completing the square, you want to take something and get it back to this format. We want it to look like this.
It's got to go through. Right, exactly.
So this x squared plus 6x plus 9, we have to figure out, well, how can we take these numbers here, the 6 and the 9, and figure out what's back at this beginning part?
No, I don't have that.
So the one we've actually multiplied out, we want to say, well, how does the 25, how could we take the 25 and get back to a 5? And how could we take the 10 and get back to a 5? So what could you do to the number 25 and get it back to just a 5?
Cool. Perfect. Get you taken care of, okay? All right, thanks for sending that to me. Have a great night.
What could we do? Good. Square root it. That is correct. If you square root 25, that takes you back to a 5. What about the 10? What could we do to the 10 to get it back to a 5?
It's on her ninth grade proficiency. On that South High School. The science isn't on there.
What can we do to a 10 to get it back to a 5? Using addition, subtraction, multiplication, division, anything we want to do to it, how can we get it back to that 5?
It's not science. Those are on the south.
Welcome, Natalie. We're currently talking about completing the square. And you are correct, dividing by 2 in our chat box. So if you want to see what's going on with the chat, make sure to open your chat so you can see it as we're working. So the 10 divides by 2 to get to a 5. The 25 square roots to get to a 5.
And we have that already on our profile.
So if we have this x squared plus 6x plus 9, we have all the information we need to figure out what number goes in this perfect square binomial. And since we know both numbers, we could do either option.
But that says that she passed the science.
So if we take the 6, let's look at this middle term. The 10 was in the middle and we divided it by 2 to get back to a 5. We're going to do the same thing to that 6. If we do 6 divided by 2, that gets us to that value of 3.
Is what? Oh.
So that's our perfect square binomial.
It's Shauna. Oh, right.
Now, it's not always presented like that. A lot of the time, they say, well, find that last number. So when you need to actually fill it in and find the last number, we have to think about it a little bit differently. But we have to remember how it was all related to each other. So they only gave us the middle number. And I probably should have picked a different one. I'm going to change it really quick because we did a problem with 10 on the previous page. So I'm going to make this an 18. So we know that this middle number can help us figure out the number that went in this perfect square binomial in the parentheses. We took the middle term and divided it by 2. This particular question, though, wants us to fill in a value. What value would we need here for it to actually become this perfect square binomial, to make the correct change? So I'm going to go back a page so we can look again at the relation. The 10 was divided by 2 to get to the 5. And if we want to go forward to the 25, instead of knowing the 25 and going back to the 5, if all we know is the 5, to get to the 25, we square it. So here, we did the middle term divided by 2, and now we're going to take that answer and square it, and that gives us this last number. When you're actually doing the whole process of completing the square, you've got to fill in this value itself. Sometimes we write it, we say that this is b, the middle term is sometimes represented by a b. So we say b divided by 2 squared. That's kind of a little formula for it. So if we did the next one, we're trying to find this blank spot. We're going to do the same process. If we take the middle number divided by 2 and square it, what number fills in this blank spot?
I'm so glad that you caught that.
And you can either unmute yourself and answer, or you can type in the chat box.
Yeah. Yeah. And then I was like, no, that's not the Jesse has. Because I work with the Shauna Hill. I work with Shauna Hill all the time. So I think I just, in my mind's eye, I was just like,
64?
Very good, 64. Negative 16 divided by 2 is negative 8.
but what?
And negative 8 squared is a negative times a negative, which makes positive 64.
All of them are passed.
So let's say we need to do the whole process now of solving. When you want to actually go through and solve a quadratic equation by completing the square. This setup is a little different than we've seen so far. Like I said, we had to build up to this. When we do the completing the square, we actually want this spot to be blank. So we want to move that 5 over first. So to do that, we need to do opposites. What's our opposite of adding the 5?
Yeah.
Subtract it from both sides.
Subtract it from both sides. Good.
It says they're passed.
And since we're doing the process of completing the square, we're going to actually leave this spot blank because we need to actually work with it and figure out what number to put there. Since this is an equation, though, what you do to one side, you do to the other. We're also going to add the same number to the other side. And this is why completing the square is so hard. It's because you have to remember, you're actually just adding in a completely new number. But we do that same process. We take the middle term divided by 2 and then square it to figure out the blank spot. So what number do we get if we take the middle term divided by 2 and then squared?
Okay, that's confusing.
16x squared.
Close, just the 16. We only take the coefficient. We don't worry about the variable. So 8 divided by 2 gave us the 4, and then 4 squared gave us the 16. So the other side, 24 plus 16, we can just combine together. Gives us 40. And then the left side, this is where we needed those binomials squared. I'm going to go back to the first page again. This x plus 5 squared, or taking this 3 terms and writing it as a binomial squared, that's our step we want to do here. We want to rewrite this as the binomial squared. So the question is, what number goes inside the binomial squared? We've actually already found it. It happens in the middle of our process. It's not the final number of 16. We get that middle number of 4. So now we have to do an opposite, though, to solve for x. We're almost ready for question time, just any questions you have, but I want to finish this problem really quick since we're in the middle of it. So what's the opposite of squaring something?
Square rooting it?
Good.
Not even like same letters, but yes, let's go.
You do have to remember when you square root with an equation, we need 2 possible values. There's a positive version and a negative version. So we're going to need a calculator for this to do the square root of 40. And just to remind you, go ahead and keep yourself muted when you're not actually talking because we can hear some background noises. But then when you're ready to answer a question, unmute yourself, just so we don't have the background. I already have enough background noise at the office that I can't get rid of. So it's nice not to have too many background noises. So when we do square root of 40, we can just go to our calculator and type in, oops, sorry, Google Calc does it square root button first, then 40. Every calculator is different. Some you type 40 in first and then hit the square root button. Some you hit the square root button, then 40. Gives us 6.324. In the algebra course, I think it always asks you to round to the 10th. So we're just going to say 6.3. Now the reason there's 2 versions, a positive and a negative, is because square root is saying what number multiplied by itself is 40. Well, positive 6.3 times a positive 6.3, and again, that's an approximation, so it'll be close to 40. That's a 40. But also a negative times a negative still makes a positive 40. So that's another weird step of this. You have to remember one's plus, one's minus, and then you have to physically split it up into 2 to finish solving. So you're always going to have 2 answers when you're solving any quadratic equation. Almost any. There's occasionally where you get 1 answer. Most of the time, it'll be 2 answers. So now we just do regular equation work and do the opposite on each side to get your 2 final answers. One is 2.3 and one is negative 10.3. Okay, so sorry I bled into question time a little bit. I just wanted to finish that before we went to general questions. So everyone might be in different courses, but you're welcome to ask a specific question from your specific course that you might be having trouble with. And you can either unmute yourself again to ask a question or type it into the chat box.
Okay, so you can put that on. Thank you. Are you just like on a home computer or a home network, or are you?
Well, if I don't get any questions, I'll move on to graphing calculator. I'll give you a little bit more time. Okay, can you explain how to do angle of depression? So this is a geometry topic. So in the geometry course, it'll have, I think one of them is like a boat, and I have no artistic skills, especially with a mouse, so they're gonna not be great pictures. But you'll have a boat and maybe like a lighthouse up on some cliffs. And maybe you have a submarine under the water. So these could all be connected by line of sight. If you had someone on the boat, they could be looking up at the lighthouse. Or if you had a person at the lighthouse, they could be looking down at the boat. Or same thing, you could have someone looking down at the submarine or up at the person. We also always keep in mind that if the person was looking straight forward, you'd have lines just going straight. So elevation is if the person needs to look up to see an object, and depression is if a person needs to look down at an object from their normal line of sight. If you're looking straight ahead, but then you have to look up at the lighthouse, say this is a 32-degree angle to look up at the lighthouse. This is an angle of elevation because the person looked up. If instead they had to look down at the submarine, that's an angle of depression. Because when the person's normal line of sight looking straight forward gets moved to look at the submarine, they have to look down. So the person on, if someone's on the submarine, they can only look up. From the submarine to the boat is only elevation. We'd have to add another element to the picture. Maybe we have a whale down here. Yeah, this is gonna be a really crappy whale. There's my whale. Kind of looks like an airplane. So you could say, now we have an angle of depression because they could look down at the other object. And they'll always tell you where to start and where to finish. So if I said, what's the angle of depression from the lighthouse to the boat? The 24 is depression because you're looking down, and that's the angle from the lighthouse to the boat. If they said, what's the angle of elevation from the boat to the lighthouse? That's our 32. So any other questions or any other questions on this specific topic? Again, you can have any topic you want, or if you have more questions on this, let me know.
I'm just going to check some of the information I have, make sure it's all correct and everything.
Usually, so if I'm understanding your question correctly of what you want explained, usually these questions are find the angle of depression from the boat to the submarine. That particular question, the only answer is 43 degrees. It's the actual angle measure from the boat to the submarine. The other part of this section is actually finding like the tangent or sine or cosine, which can use an angle of depression, but then you have to set up another equation. So do you want to see some about tangent, sine, or cosine? Okay. So if we involve tangent, sine, or cosine, a question I think I've seen a couple of times is about an airplane. So if you have an airplane flying, again, sorry about my art, it's just not going to be good. Let's pretend this is kind of an airplane. If you have an airplane flying and it's making a descent, let's say we know we are 500 meters away from the landing strip, and we want to know how high the airplane is right now. So it'll be some sort of question like this. An airplane is descending. How high in the air is the airplane? It's not the exact way it will be worded, but since I'm doing this from memory, that's what we're gonna have to go with. So on any right triangle, the actual right triangle is the 500 meters and the x. We can use tangent, sine, and cosine. But we do have to make sure we have the angle in the correct spot. So this angle is currently outside the triangle. We know that when you have two parallel lines, the top line here and the very bottom line, when you have two parallel lines, this 12 is also down here. This is a transversal that cuts through, and so it's called technically alternate interior, but you can also just kind of tell they're about the same size. So we put the 12 degrees inside here, and then we have to decide, well, do I use tangent, do I use sine, do I use cosine? They each have their own specific formula. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Over hypotenuse, and tangent is opposite over adjacent. So all of these are in relation to the angle they gave you. They gave us the 12 degrees, which we located down here in the triangle. So knowing that and knowing where the 90 degrees is, we can decide, well, which of these sides is considered hypotenuse, which one's considered opposite, which one's considered adjacent. And then from there, we can determine, well, what formula do we use? I always start by identifying the hypotenuse first, and it's the side across from the right angle. If you took this right angle and turned it to an arrow, it kind of points to the side across from it. Or I think of it as the side not touching the right angle. This side X actually touches the right angle, or the 500 meters touches the right angle. So the one across from it is this side. So 12 degrees, that's where we want to look at next. Opposite the 12 has the same concept as finding the hypotenuse. We want the side not touching the 12 degrees. So which side doesn't touch the 12 degrees, the X or the 500? Which one's opposite? X. X is opposite, good. And then adjacent is the only side left. And it's the one touching the 12 degrees that's not the hypotenuse, or touching whatever angle you were given. So opposite is labeled with an X, adjacent is labeled with 500, hypotenuse doesn't actually have anything. 12 degrees is not the side, it's actually the angle inside. So we're gonna erase hypotenuse now and say this one's not important to our question. So from our three formulas, sine, cosine, or tangent, which formula uses opposite and adjacent?
Tangent?
Good, tangent. That's the formula we're gonna use for this particular question. The other two don't apply because we don't have any information about the hypotenuse. So we plug in all our information now, and the A stands for the angle. So tangent 12 degrees equals opposite, which was labeled with an X, over adjacent, which is labeled by a 500. So once you have the equation set up, now we're just trying to solve the equation. How do we solve an equation like this? What opposite operation would we use to get X alone?
Would you multiply by 500 on both sides?
Correct. Multiply by 500. Some students prefer only to write it on the other side, just to have a little less clutter. We say, well, the opposite's going to cancel the 500, or you can just times it and cancel it out. Okay. So at this point, you must use a calculator. If you do not have a handheld calculator, you can download a calculator app, or you can just go to Google Calculator or any online scientific calculator. You do want to make sure it'll say RAD or DEG. Radians is a different way to measure an angle that you have not learned about yet. We want it to say DEG, or else your calculator will give you the wrong number. Welcome, Calvin. We're finishing up a question on trigonometry, and then we'll talk about how to use a graphing calculator. So you want to make sure your calculator says degrees, and then we just type it in, 500 times tangent 12. And then we just hit equals, and it tells you the correct answer. Again, most of the time you're rounding to the 10th. So this 2 will round up to a 3 because the 7 next to it is 5 or bigger. So 106.3. And in this case, we had a measurement of meters, so 106.3 meters. Okay, so let's talk about how to use a graphing calculator. If you have any more just general questions, we'll have the last 15 minutes at the end as well for more questions. So when we're using a graphing calculator, usually you'll be asked to graph something. You'll see this a lot with graphing lines or graphing systems of equations. There's a lot of different ways to use this graphing calculator. I usually use this online one, Desmos.com. Again, you may own a handheld one. That'll be a little bit different than using Desmos. Desmos is pretty straightforward though. When you go to the site, let me see if it pops up when I type it in. It should, yeah. It'll show up like this at first, and you can say start graphing to actually get to the graphing features. Or if you want a scientific calculator, they do have a scientific calculator as well. Okay. And when you say start graphing, it just takes you to this page. So let's maybe say we have a system of equations to solve. And a system of equations has 2 lines basically, and they can be written in any format. So the advantage of Desmos over, say, a handheld graphing calculator is on Desmos, we can actually just directly type each of these in. You don't have to change a thing. We just type in 2x minus 5y equals 12. So you go to this box, you can either literally type it in on your keyboard, or, so let's type in the second one, y equals 4x minus 8. So then if you have a second graph to actually graph, second line to actually put on the graph, you click below into this box. If you don't have a keyboard, or if you prefer, you can use their little manual keyboard that you click on. It's y equals 4x minus 8. And you'll see it'll pop up the 2 lines. So if you're just looking for a picture, some questions with graphs, you'd be done. If they want you to actually solve, like that system of equations, we want where the 2 lines cross each other. You'll see it has little gray dots some places. Those are just important key features. We want the gray dot where they cross each other, and it actually gives you a coordinate. I'm going to round again 1.6 and negative 1.8. So that's your actual solution if you're solving a system of equations. Again, it kind of depends on what the question is asking for. So they may want you to actually solve. Maybe you just want to find an intercept intercepts. And again, on Desmos, it doesn't matter what order all of this is written in if you're using the graphing calculator. So 2x equals 6y plus 4. So if you want to get rid of 1, you can hit X. Or if you just want it to not show up anymore, but you don't want to erase the equation, you can click this dot, and that takes it on and off. And I already forgot the equation, 2x equals 6y plus 4. 2x equals 6y plus 4. So this time it only asked for the intercepts. We're only going to have one line up, and that's where it crosses the x or y axis. X-axis is the left to right, y-axis is the up or down. So the x-intercept is 2, 0, and you can actually click on it and have it stay up instead of just hovering. So x-intercept is 2, 0, and the y-intercept is 0, negative 0.7. I'm going to round to the nearest tenth again. So that's how you graph a line using this particular graphing calculator. You might also be asked to graph a quadratic. So they start getting more complicated. Equals 2x squared minus 5x plus 3. So again, if you're on this online graphing calculator, this is the best online one I've found. If you have a handheld one and you have questions about it, feel free to email me or send me a chat and I can talk to you individually about it. Every graphing calculator works a little bit differently. So when you type this in, we need to get to x squared. We have y equals x. This time it helps to pull this part up because this a squared means it's going to put that little 2 up. So y equals x squared, and I think I forgot. Okay, so I forgot part of it. I forgot the 2 in front. You can just click it and add it in. Equals 2x squared minus 5x plus 3. So again, maybe they ask you for intercepts. We can find these important key points. Or you'll see a new dot. This one is the vertex of the quadratic. The very bottom point is the vertex. And the last thing that you might need to worry about, let's say that instead of 3, this was 30. So it looks like nothing happened. We have 2x squared minus 5x plus 30. Didn't give us any sort of error message. We just can't see anything. So then you may want to zoom out to see if maybe it's up higher. Or you can click and drag to make stuff go down or up while you're using this calculator. And if you want to reset it, if you're like, well, I don't want it so big, you can hit the default zoom to get it back to the regular calculator. If you're in Algebra 2, you may be asked to even graph a more advanced function than this. You'll see on this bar down at the bottom the word functions. And you can graph trig functions. You shouldn't ever need this page, but you can graph like absolute values, ABS, or exponential or logarithmic. But if you're in Algebra 1 or Geometry, you would never need any of these. You would need just the basics. So any questions about the graphing calculator itself? We've pretty much covered this online. Like I said, if you have a handheld one, it might work a little bit differently. And I'd be happy to either find YouTube videos or answer direct questions. It's hard to know what calculator everyone has, though. I really recommend this online one, though. It's super easy to use, super straightforward, so it's kind of nice to work with. Let's just go back to regular questions then. A little early from the graphing calculator section, but we covered everything on that. So any other questions you might have for your specific course, you can either enter into the chat box or unmute yourself and just say your question out loud. Or any questions about final exams or when stuff is due. I'm happy to answer any questions you have about how the course works. Well, if no one else has any questions, I think we'll stop a little early today. I'll give you just a little bit longer in case you think of something. So the live sessions, good question. So the question was, will you do another live session soon? The live sessions are once a week, every week at this time, for me running them. There's a couple other math teachers. I don't remember the exact times they do. They don't work full-time like me, so I think it's only once or twice a month. But I will do ones every Thursday. Or you can send me a chat if you come up with a question during the week, or you can send me an email. I had this up at the beginning, but just so you can see it again in case you didn't get it down. I even have a number to text. If you come up with a question and you just want to text me really quick, or you can send me chat messages. So lots of ways to contact me if you have questions during the week, or if you want to join me again next week, we'll do another session next Thursday at the same time. Any other questions? Well, I don't see any other questions, so thanks very much for joining me today. If you do have questions, again, contact me, and I will hopefully see you guys next week. Have a great day.